In the present lecture, we will discuss the multiple or alternative optimal solution of assignment problem. The situation get a more than one optimal solution with the same optimal value of the objective function is called as the multiple or alternative optimal solutions. While making an assignment in the reduced assignment matrix, it is possible to have two or more ways to strike off a certain number of zeros. Such a situation indicates that there are multiple optimal solutions with the same optimal value of the objective function. This is we will be discussed with the one example problem. Let's see the problem. How should the jobs be assigned to the various missions so that the total cost is minimized? So here given the cost matrix for the 4 jobs with the 4 missions. Let's see the solution. This assignment problem we can be solved by applying the Hungarian method. In the Hungarian method, phase 1 is row and column reduction. First we will go for the row reduction by subtract the minimum value of each row from the entries of that row. Then determine the minimum value of the each row of assignment matrix. In the first row, minimum value is the 5. In the second row, minimum value is 5. In the third row, minimum value is the 4. And in the fourth row, minimum value is the 3. Then subtract this minimum value, that is 5, from the first row. Then the row 1 becomes the 5 minus 5, 0, 7 minus 5, 2, 11 minus 5, 6, 6 minus 5, 1. Next subtract the minimum value 5 from the second row. Then the row 2 becomes the 8 minus 5, 3, 5 minus 5, 0, 9 minus 5, 4, 6 minus 5, 1. Next subtract the minimum value 4 from the third row. Then the third row becomes the 4 minus 4, 0, 7 minus 4, 3, 10 minus 4, 6, 7 minus 4, 3. Similarly, subtract the minimum value 3 from the fourth row. Then the row 4 becomes the 10 minus 3, it is the 7, 4 minus 3, 1, 8 minus 3, 5, 3 minus 3, 0. Next we will go for the column reduction by subtract the minimum value of each column from the entries of that column. So in the first column, minimum value is 0. In the second column, minimum value is 0. And in the third column, minimum value is the 4. And in the fourth column, minimum value is 0. So first, second and fourth columns are having the minimum value is 0. So no need to modify for these columns. And in the third column, minimum value is 4. Then subtract the 4 from the third column. Then the third column will become the 6 minus 4, it is the 2. 4 minus 4, 0. 6 minus 4, 2. And 5 minus 4, 1. Next we will go for the phase 2, that is optimization of the problem. In the phase 2, first step is draw a minimum number of lines to cover all the zeros of the matrix. For this, go for a row scanning and start with the first row and observe if there is exactly 1 0, then mark a square around the 0 and draw a vertical line which is passing through that 0, otherwise skip the row. So here observe the In the first row, there is exactly 1 0. Then mark a square and draw a vertical line which is passing through that 0. And in the second row, there is more than 1 0. Here in the second row, we are having the 2 zeros. So we have to skip the second row. In the third row, there is no zeros. So we have to skip the third row. And in the fourth row, there is exactly 1 0. And mark a square and draw a vertical line which is passing through the that 0. After scanning the last row, check whether all the zeros are covered with the lines. If yes, go to the step 2. Otherwise, go for the column scanning. Here, after the row scanning, 2 zeros are not covered with the lines. Then I have to go for the column scanning. In the column scanning, start with the first column and observe if there is exactly 1 0, then mark a square around that 0 and draw a horizontal line which is passing through that 0. Otherwise, skip the column. So first column is already removed by the row scanning operation. And next observe in the second column. In the second column, exactly 1 0. Then mark a square around that 0 and draw a horizontal line. And in the third column, there is no zeros, so skip it. And fourth column also, there is no zeros, then I have to go skip the fourth column also. After scanning the last column, check whether all the zeros are covered with these lines. So here, all the zeros are covered with the lines, then I have to go for the step 2. Next step is check whether the number of square marked zeros is equal to the number of rows of the matrix. If yes, go to the step 5, otherwise go to the step 3. Here, square marked zeros are the 3 and number of rows are the 4. So, number of square marked zeros are not equal to the number of rows of the matrix. Then I have to go for the step 3. So, step 3 is the identify the minimum value of the undeleted cell value. Then add the minimum undeleted cell value at the intersection points of the present matrix and subtract the minimum undeleted cell value at the undeleted cell values and remaining entries are the same. So here these are the undeleted cell values. Among these one, minimum value is the 1. So minimum value of the undeleted cell value is equal to the 1. Then we have to add this minimum undeleted cell value at the intersection points of the present matrix. Here intersection points are the, that is intersection of the horizontal line and vertical line. That respected cell values are the 3 and 1. So here we have to add this minimum value of the undeleted cell value to the intersection points. Then the 3 plus 1, it is become the 4 and 1 plus 1, it is the 2. So next we have to subtract the minimum undeleted cell value at the undeleted cell values. Now we have to subtract the value 1 from the undeleted cell values. Then matrix will become 2 minus 1, 1 and 2 minus 1, 1 and 3 minus 1, 2, 2 minus 1, 1, 1 minus 1 is 0 and 1 minus 1 is the 0. And next remaining values are no need to change. Next to draw a minimum number of lines to cover all the zeros. For this, first we have to go for the row scanning. In the first row, there is exactly 1 0. So we have to mark a square around that 0 and draw a vertical line. In this second row, there is 2 zeros. So we have to skip the second row. In the third row, there is no zeros. So we have to skip the third row. And in the fourth row, there is more than 1 0. So we have to skip the fourth row also. After the scanning of last row, still there is all the zeros are not covered with the lines. So we have to go for the column scanning. Here, first column is removed by row scanning and second column is having the more than 1 0. Then I have to skip the second column. And in the third column also having the more than 1 0. So I have to skip the third column. In the fourth column, there is exactly 1 0. So we have to mark a square around that 0 and draw a horizontal line. After the row scanning and column scanning, still all zeros are not covered with the lines. Then again repeat the row and column scanning. In the row scanning, second row having the more than 1 0, then I have to skip the row scanning, then I have to go for the column scanning. In the second column, there is having the exactly 1 0, then we have to square a mark around the 0 and draw a horizontal line. Now all the zeros are covered with the lines. Then I have to go for the next step. Next step is check whether the number of square marked zeros is equal to the number of rows of the matrix. If yes, go for the step 5. Otherwise, go to the step 3. Here, square marked zeros are the 3 and number of rows are 4. So, number of square marked zeros is not equal to the number of rows of the matrix. Then have to go for the step 3. Step 3 is identify the minimum value of the undeleted cell value. Here, after that one, add the minimum undeleted cell value at the intersection points of the present matrix and subtract the minimum undeleted cell value at the undeleted cell values and remaining value should be the same. Here these are the undeleted cell values. Among this one, minimum value of the undeleted cell value is the 1. So we have to add the 1 at the intersection points of the matrix. Here intersection points of the matrix is, that is intersection of horizontal line and vertical line of the respective cell value. Here 4 and 7 are the intersection cell values. So we have to add the minimum value of undeleted cell value at these points. So 4 plus 1, it is the 5 and 7 plus 1, it is the 8. Next we subtract the minimum undeleted cell value, that is 1, from the undeleted cell values. Then 1 minus 1 becomes the 0 and 1 minus 1 0, 1 minus 1 0 and 2 minus 1 1 and 1 minus 1 0, 3 minus 1 is the 2 and remaining values no need to change. Next, draw a minimum number of lines to cover all the zeros. First we will do the row scanning. In the first row there are multiple zeros, so we have to skip the first row. Similarly in the second row also there are multiple zeros, then I have to skip the second row. In third row also there are multiple zeros, then I have to skip the third row. Moreover, in the fourth row also there are multiple zeros, then I have to skip the fourth row also. Next we will do the column scanning. Here also all the columns are having the multiple zeros. So it is not possible to draw a line which cover the all the zeros. So in this situation, we can apply the diagonal rule. Diagonal rule is used when multiple zeros are present in the reduced cost matrix. Then select a zero which is having the other zero, that is diagonally opposite to another row or column. Here in the first row, if we selected this 0 which having the diagonally another 0 in the next row. So we have to select this 0 and mark a square around that 0 and draw a vertical line. Similarly, next we have to select this 0 in the second row, which having the another 0 diagonally in the third row. Then have to select this 0 and mark a square around that 0 and draw a vertical line. Next in the third row there is only one 0. Then I have to select it and mark a square around that 0 and draw a vertical line. And in the fourth row also there is only one 0. So we have to select and mark it and draw a vertical line. So next we have to move to the another step. Before that one I have to observe here. So number of square marked zeros and the number of rows. Here number of square marked zeros are the 4 and number of rows are 4. So number of square marked zeros are equal to the number of rows. Then I have to move to the step 5. So step 5 is the treat the solution as marked by the square. Now optimal assignment is job 1 is assigned with the machine 1 and job 2 is assigned with the machine 2 and job 3 is assigned with the machine 3 and job 4 is assigned with the machine 4. And for optimal cost we have to check the initial cost matrix and write down the cost for a assignment, that is for the job J1 with the machine M1 is the cost is 5 rupees and for the job J2 with machine M2 cost is the 5 rupees and for the job J3 with the machine M3 cost is the 10 and for the job J4 with the machine M4 cost is the 3. Then total cost will become 5 plus 5 plus 10 plus 3, that is the 23. So optimal cost of assignment is 23. In this problem, we can be draw a minimum number of lines in the another way also. By applying the diagonal rule, we can be select this 0 which is having the another 0 in the diagonal position. So mark a square, then draw a vertical line. Next in the second row there is only one 0. Then mark a square around the 0 and draw a vertical line. In the third row also there is exactly one 0. So mark a square around that 0 and draw a vertical line. In the fourth row also there is exactly one 0 and mark it, then draw a vertical line. Here square marked zeros are 4 and number of rows also 4. So number of square marked zeros are equal to the number of rows. Then have to move to the step 5. Step 5 is the treat the solution as marked by the square. So here optimal assignment is job J1 with machine M2, job J2 with machine M3, job J3 with machine M1, job J4 with machine M4. Then optimal cost of assignment is, so for the job J1 with machine M2 cost is the 7. And for the job J2 with machine M3, cost is the 9. Job J3 with machine M1, cost is the 4. And job J4 with machine M4, cost is the 3. So total cost is the 7 plus 9 plus 4 plus 3, that is total optimal cost of assignment is 23. Previously we draw a minimum number of lines in the two ways. We can draw a minimum number of lines in the another way also. By applying the diagonal rule, we can select this 0 which having the another 0 in the diagonal position. So select this 0 and draw a vertical line. Next we can select this 0 which having the 0 in the diagonal position and draw a vertical line. Next we can select this 0 which having the 0 in diagonal position and draw a vertical line. And in the fourth row there is only one 0, then I have to select this 0 and draw a vertical line. Here observe the square marked zeros are 4 and the number of rows also 4. So total number of square marked zeros are equal to the total number of rows. Then I have to move to the step 5. So step 5 is the treat the solution as marked by the square, and the optimal assignment is job J1 with machine M4, job J2 with machine M2, job J3 with machine M1, job J4 with machine M3. And optimal cost is for job J1 with machine M4, cost is the 6, and for the job J2 with machine M2, cost is the 5, and job J3 with machine M1, cost is the 4 rupees, and job J4 with machine M3, cost is the 8 rupees. Then total optimal cost is 6 plus 5 plus 4 plus 8, total is the 23 rupees. For this given problem is having the multiple solutions and having the same optimal value. Total optimal cost is 23 rupees. So this is the solution, and thank you.